look at the solutions. So for rational equations, obviously these are going to involve an equal sign for equations, and inequalities will be having inequality signs like that. So your rational expression here, let's scroll that up. So rational expressions and equations. So rational expressions are simply ratios of two polynomials. So these are your two polynomials. So this is a quadratic polynomial on the top, and this is a linear. So anything that's written like this is a rational expression. So it could be a cubic. It could be x cubed plus 3x plus 1 on 2x squared minus 5, something like that. As long as these are polynomials on top and on the bottom. And the simplest one we drew before was y equals 1 on x. Okay, so this is your reciprocal graph. So that actually looks like that. Okay, and most of your rational functions are going to look something like this. Generally, they're going this way, or they may go this way. For example, you could have one which goes like this. I don't know, something like that. So the graphs are quite variable, but they all look something like this. So these are some other examples of your rational expressions. You've got a linear on top here, and this is a linear on the bottom. This one's quadratic polynomial. You have linear here. Then you have a cubic polynomial on top, and this is a quadratic polynomial on the bottom. So all of these are rational expressions. They're made up of two polynomials. So P, you could write P, X, QX on the bottom. So these are both polynomials. So some of them aren't polynomials. So for example, when you have a square root X, because remember, polynomial can't have fractional powers. So this is X to the half plus 3. So you can't have a fractional power in rational expressions. And this is a exponential, so you can't have your power being X. Okay, that's not allowed. And this is a trigonometric expression here. So you've got a sine function on a linear function. So these are not polynomials because they're not ratios of polynomials. So they're not rational expressions. Okay, so let's go down a little bit and see what's here. So these are some expressions that are, some identities that are useful when you're simplifying. And you've done these already, so I'll just breeze through that. These are all ones that you use for simplifying. So the first thing we'll just do a few questions just to give you the idea what's going on. We'll try to solve equations first. So solving rational equations. So we've got 1 plus 1 on x equals x. This has a rational part here, 1 on x. So for doing this one, we would clear out the x first. So when we're trying to find x, we don't want to have x here. So x is multiplied by both sides. So now we're just trying to find x. So multiply x both sides, and you'll end up with, that should be 1. So let's see, x plus 1. There should be 1 here. I don't know what happened there. X squared minus x. Oh, this becomes plus 1 is, yeah, okay. So we end up with a quadratic. Okay, I just misunderstood what I wrote myself. So you end up with a quadratic, and you basically solve that with the quadratic formula, and you'll end up with some irrational solutions because of the root 5 there. So this one, okay, we've got a t minus 1, and this is a 2 in the denominator. So what they do here, or what I did, I multiplied this one by 2 top and bottom to be 2 on 2. And then this was combined together here. So this was combined into this part here on the right side. And then we can cross multiply at that point. So then the 2 can come up like that, and the t minus 1 can come up here. So let's go through that. This ended up being, well, that looks like a cubic. Okay, so this would be simplified to a cubic equation. And then that can be factorized out t, which is here. So we factorize our t, and then you have a quadratic, which is factorized. And you end up with 3 solutions here. Okay, it's a bit of information you can read here yourself later in the book. We'll leave that one. Let's just go down. Maybe we'll do some questions. Okay, so we're going to do a couple, 2 or 3. We don't need to do a lot on this because the method's the same for every question. Okay, so if you look at this question here, you've got a 3 and you've got a 5x plus 4 here. So I would multiply 5x plus 4 both sides. So you can copy this down. Exercise 5. And 5x plus 4. Like that. And this will cancel out. So you'll end up with x equals 3, 5x plus 4. Okay, and then we'll just expand that. So what would you get? X equals 15x plus 12. So you're going to have 15x minus x. That would be 14x. And if you put 12 on the other side, you'll get minus 12. So x is minus 12 on 14, which is minus 6 on 7. So that should be the answer here for x. So these questions are just solving equations, which you've already done before, but maybe the method you might have forgotten because we did these, I think, in grade 9. Okay, why don't you try this one yourself? So I'll leave you a couple of minutes. I'm not going to ask for your answer, but if you want to put your answer in the chat, do that. So you've got y squared plus 1 in the denominator. So to get rid of this denominator, multiply that by both sides. So y squared plus 1 and y squared plus 1 and cancel that. Okay, you try and simplify that yourself. I'll give you a couple of minutes, try that one. So there's more examples there you can read later yourself if you want. This one would be a quadratic. Okay, so do that one. So today we're at this part, we're just solving equations. We're not graphing, we're not doing anything like that. They can be solved by graphing, but you wouldn't bother. Because the graphing method for this question would be quite difficult, I think. I got one answer. So if you know your answer, 2-1. Yeah, 2-1 is the correct answer. That's snipper. So if you keep going, you should get 2-1. Can you try that? And let me know if you get 2-1 or not. So just expand it, rearrange it, and factorize. That's all. So nothing special about this question. And the next question, I'll show you how to join that fraction. So if you have finished this one, go and look at C while you're waiting. Think about how you would do C. Okay, we got any more answers? 1 and 2. Yeah, so for this question, when we multiply y squared plus 1, this will cancel out this side. So you have 3y minus 1 equals y squared plus 1, because the y expanded, we'll just give that again. So y squared plus 1 minus 3y plus 1. If you bring these to the other side, you get equals 0. So y squared minus 3y plus 2 equals 0. So what numbers multiply to give 2 but add to give minus 3? Well, they both have to be negative, don't they? So y minus 1, y minus 2. So minus 1 minus 2 is 2. Minus 1 minus 2 is minus 3. So that's correct. So y is 1 and 2. Now, when you're doing these questions, you should go back and check. Also check here. So check your solutions are actually okay when you put them back in. So when you get to these more complicated equations, we need to be checking these and check they both work. So question C, you kind of recognize, see what you got here. You got y plus 3, y minus, w plus 3, w minus 3, and w squared minus 9 here. So what I would do, I'd probably try to join this together here. So why don't we try to put that as one fraction? Now I'll show you a sort of a quick way to do fractions. So if you had 2 on 3 plus 3 on 4, okay, this is how I would do this a kind of a quick way. So 3 4s are 12, aren't they? So I write that as the denominator. Now 3 into 12 is 4, and 4 times 2 is 8. 4 into 12 is 3. 3 times 3 is 9. So this is a quick way you can do fractions. So let's do another one. 2 on 5 plus 3 on 6. Okay, so what I would do here, 5 times 6 is 30. Okay, 5 into 30 is 6. 6 times 2 is 12. 6 into 30 is 5. 5 times 3 is 15. So you got 27 on 30. So I think this is kind of a quick way for adding fractions. But I'm kind of doing the method of adding fraction, but I'm kind of summarizing it in my head. Okay, so if you did that here, you would have w plus 3, w minus 3. So that's like your 12 here, 3 4s are 12. But obviously, I'm not going to put that together. I just leave it like that. So w plus 3 into this will give w minus 3. And w minus 3 times 1 is w minus 3. Plus w minus 3 into this gives w plus 3. W plus 3 times 1 is w plus 3. I hope that made sense. You can do it the long way if you want, but I want to try and make one fraction. So here we ended up with 2w. And this actually here, this part is our difference of squares, isn't it? It's actually the same as that, w squared minus 9 equals w squared minus 3 on w squared minus 9. Now, actually, if you have a denominator which is the same in both fractions, you could cross multiply it, but they're going to end up disappearing. So if you, for example, if you go w squared minus 9 both sides, it will just cancel, wouldn't it? It would be gone. So what I do here, I would just knock out that fraction in the bottom. So if you have two fractions that are the same in the denominator, we can cancel them. So that's another trick you can learn. So if you have two denominators the same, ignore it. And then just look at your numerator here. So then I can write 2w equals w squared minus 3. So w squared minus 2w minus 3 equals 0. So w minus 3, w plus 1 equals 0. So w is 3 or minus 1. Now, before we write our final answer, remember I said you should check this answer here. Okay, so if the problem is with the 3. You see this 3 here? Now, if I put 3 in here, I'm going to get 2 times 3 on 3 squared minus 9 equals 3 squared minus 3 on 3 squared minus 9. So the problem is here because you're going to get 9 minus 9, which is 0 in the denominator, and you're not allowed to have that, are you? So if you put 3 into this equation, it's not a solution to this equation because your denominator will be 0 in both cases, on both sides. So even on one side, if you get a 0 denominator, that 3 cannot be a solution. Okay, but if you try -1, you'll find -1 will work. So only -1 is the answer there for that question. All right, that's a bit tricky because you got this like a complicated fraction in the denominator there. Okay, I'll leave it there for a minute if you're copying, but try an easier one, which is D. Can you do D? And if you like, you can put your answer in the chat box. So calculate X here. And notice here, X can't be -1. You see here, if you've got X is -1 as an answer, you're not allowed to use it because this ends up as 0. So we'd have to say X cannot equal -1 in that case. In this case, W can't be 3 or it can't be 3 or -3. So like that, because we'll end up with zeros here on this side. Okay, you try D by yourself for a while. See how you go. This one's a quadratic again, an easy quadratic. So try that. And when you've done the answer, put it in the chat box. So it should just take a couple of minutes. Write that out. So I'm going to have to redo some of your books for semester 2 to kind of shorten them a little bit. And hopefully we can cover the work properly for the second semester. When we're at school, it's okay. We have time to do things, but when we're online, I think we are probably doing less than what we can do in class. So two and -6, yeah. So for question D, you should get 2 and -6. So just check you get those 2 answers. I'll write them here and we'll see how to get them in a minute. That's the answer. And they both should be okay. So you put them both in the equation and check they work. So if you have time on a test, you should always substitute your answer back and check the solution. So just put your answer in if you could actually get that. So I know you're actually doing it correctly, Panavit, yeah. So 2 and -6 should be the answer. So if we're going to solve it, we've got an X plus 1 in the denominator. So let's multiply X plus 1 both sides. Cancel out that denominator. So you have 2X plus 17 equals X plus 5. X plus 1. Let's not forget that. So 2X plus 17. We don't need a bracket. So 2X plus 17 equals X squared plus 5X plus X plus 6X plus 5. Okay, I've just expanded in my head there. So then we put it all together. X squared plus 6X minus 2X plus 5 minus 17 is 0. So we'll have X squared plus 4X. 5 minus 17, that's minus 12 equals 0. So X plus 6, X minus 2 equals 0. 12, 6 minus 2. Okay, so X is minus 6 and 2. And it should be okay. The main problem you'll get is with the denominators here. So -1 wasn't a solution. So we should be okay. These should be all right with that question, right? Ooh, it looks difficult, but it's not really. You just really want to get this up to this side. Okay, so try that one. So even though it's, oh, hold on, before you do that, see if you can factorize anything first. Yeah, don't jump ahead like I suggested. Maybe you can simplify this first before we start moving this. So don't just stick all that up here. So I'll help you a bit with this one. Can you factorize the top line? All right, I'll help you a bit here. So you'll get a factor here. You'll get two factors here. So factorize the top line and then factorize the bottom too. You can actually factorize this bottom. You can see t is a common factor, isn't it? So you should get something like this. All right, do that for a second and then I'll show you. If you've done that, see if you can finish it. Interesting answer. So factorize first. So before you start moving stuff, see if you can factorize. That's what I should say. So let's make a note. Factorize first if possible, or factor first if possible. So see if you can factorize these before you start moving stuff around, because you might find you can simplify it. Okay, do that for a minute. If you think you get an answer, if you think you can get an answer, let me know. You can let me know in the chat box. So if we're going to factorize these, we've got t squared minus 2t plus 1. So multiply to 1, but add to be minus 2. Well, it's got to be t minus 1, isn't it? Minus 1 is 1. Minus 1, subtract 1 would be minus 2. Okay, so the top line is done. The bottom line we would factorize out. Let me just factorize that out first as t squared plus t minus 2. Okay, so I just did that second factorization there. So the top line is still the same, t minus 1 on t. So this is going to be t plus 2, t minus 1, isn't it? Like that equals 1. So now you see you can simplify a little bit. So it's going to make your life a bit easier, because if you go up here, you're going to end up with a cubic equation, and you don't want cubics. So we always try to factorize first, because if you've got a cubic, remember it takes a long time to solve that. So we can cancel the t minus 1. So now we can bring your t plus 2 to the top side. So t minus 1 equals t plus 2. So just basically multiply that both sides, this part here. So multiply that both sides. That's what I did. And then you'll cancel this out. So now this is our equation here. So you're going to have t squared plus 2t minus t plus 1 equals 0. So t squared plus t plus 1 equals 0. So who gave me an answer? Minus 1. Right, it's quadratic. Yeah, Nicole said it's a quadratic. So we got down to here. Now, we want to know, can we solve this? If you don't have a calculator with you in a TIE exam, you won't. So you're going to panic and wonder, and you're going to try and factorize it. So you can't factorize this, actually. So you should check the discriminant. So check b squared minus 4ac. Do you remember this from grade 9? And I'm gonna have to cover this in second semester because we missed it this term. So I need to go back to some quadratic, especially graphing. I want to go back into quadratic graphs a bit more and do a bit more detail about graphing. But I'm not going to go do a whole unit on quadratics, but we'll do graphing. Okay, so who gave me an answer? We can't find the answer because the number is negative the root. Yes. So if you check this, which is part of your quadratic formula, you'll have 1 squared minus 4 times 1 times 1. So you're going to get 1 minus 4, which is negative 3. So this is called your discriminant, and this is negative, which means you'll have no real solution. Because remember from your quadratic formula, minus b plus or minus b squared minus 4ac all on 2a. Well, this bit is negative here. And you can't square root negative number, which means that x does not have a solution. Now, if we were to graph this, which we'll do next term, this graph won't cut the x-axis. It can't equal 0. So it probably looks like that. You see, this is, normally we write y here, don't we? And the graph is not going to cut the y-axis. So it can't have a solution. This is t, and this is, say, y. So this graph, it would have no solution. But we'll do more on graphing next term about quadratics. I know you've done some already, but we need to do a bit more. What other questions are down there? Ooh, let's go down to G. All right, look at this one here. Now, you want to get rid of these denominators. So what are you going to multiply by? Everything that will cancel these denominators. So I might give you a few minutes to work on this by yourself. So we want these denominators gone, the stuff in blue. We don't want these here. So multiply through by something that will make these cancel out. And you'll get some kind of equation that you solve. And also x can't equal 2. So we can probably write that here. 2. You see why? Because this would be 2 minus 2, which is 0, which will give you a 0 denominator. And you can't have 0 denominators. And same for that one. Okay, so if you think you can solve that and actually do it by yourself, let's see what happens with that one. Okay, try and solve that one, see what happens. There's another way to do that. So before you start doing what I told you, what you could also do is bring this term to this side and this term to this side. This is another way to try. So you'll end up with x minus 2 on x minus 2 equals minus 2/3. And this can be made one fraction. So maybe that's an easier way to do it. So try it from this step here. Try that. But you can do it the way I mentioned as well. Okay, try that. So if you think you get an answer, let me know. 2 answers. The statement is false. Yeah, so what does that mean? That's Nicole. Yeah, so you're going to get something which is not true at the end, which means there can be no solution. So actually this here has no real solution either. Let's just write no solution. I'm not sure about if it has imaginary solution. So no solution for this one. So can you see why that's happening? So if I try to join these equations here, So let's put these two together. You have a common denominator already. So that's actually was a good idea to move these around. So you have a common denominator, which is x minus 2. And now we've got x minus 2 on the top, isn't it? So we just join those two fractions and you'll get minus 2 on 3. X minus 2 on x minus 2 is 1 minus 2/3. And this is a false statement. Okay, so you've got down to something where the x has completely disappeared. So whatever number you put in here, it doesn't matter what you put because it's going to disappear at this stage here, you see? It will become this and the x will disappear and you'll end up with a false statement. So this is false. So that means this has no real solution because it didn't matter what you put in x. You can't make this side equal to this side. It's impossible. So this has no real solution, this one. If it was equal, if you ended up with 1 equals 1, which is true, then we would say it's true for all values of x. Means, so you said if. So if that happened, if you had 1 equals 1, it means that the equation is true for all x. So the x would still disappear, but you still end up with a true statement, which means it would be true for all values of x. Okay. Now I'm going to go down because I want to go to the next section and I think we'll come back to these later and we'll do some more of these tomorrow, but I want to show you the inequalities. So what I'm going to do here, let's see the best way to do this. Okay, I'm just finding there is a couple of ways to do these. And what I'm going to do, I'm going to concentrate on this method here. Now, these get a little bit tricky. So if I said to you, 1 on x is greater than 2, and I wanted you to find what could be the values of x. So before you start, so don't follow this method here, but just think what could be the value of x that when you put the number here, that the answer will be greater than 2. So you just solve how you think you would do this. So you try and solve it. Okay, I'll give you a minute. You try to solve this. So try guessing some numbers if you want. Try guessing some numbers and see what happens with that. And then see if you can actually get the right answer by just doing how you think you would do that. And I'll show you what the problem is with your method in a minute, because I know what you're probably going to do. So you try to solve this. Tell me what you think x could be. So for example, if x is 2, it would be false. So why don't you make a table of numbers? Let's say x was, and we're saying it's either true or false here. So if x was -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, like that. So just tell me if they're true or false. You may need some fraction numbers too. And remember, we're looking for true statements. So what values of x make this true? So what do you think? If you think you know what the answer is, just put in the chat. I'll have a look. But I'm not bothered to score the chat today because this is just a bit difficult anyway. But then I'll show you the method that we will use to solve these kinds of problems. You don't want to do it by guessing, it takes too long. And make errors too. We can also solve these by graphing, but that would take forever and you'll make mistakes. So if you want to solve these by graphing, we can. but you need to use like the computer program or the website to do it. We wouldn't do graphing by hand to solve equations. But I think you'll do that with Teacher Chen next year, I'm pretty sure. Okay. So anyone have an answer for that? One on X is greater than 2. You're probably going to be in this area somewhere, aren't you? It's probably going to be down here somewhere that you're considering. Minus 1/5. Let's see. Now, I'll show you, like, if you are going to solve this, like the method we've been learning today. So some student may see that, and what they're going to do, okay, if you see that, some student might think, oh, I multiply X both sides and I'll cancel the X, right? So let's do that. So X times X will cancel. So you're going to get 1 greater than 2X, okay? Which means that 2X is less than 1. I'm just swapping them around. So X is less than 1/2. But that's only part of your answer. Do you know why? Because you see what I did here? You see that X. Now, if that X is negative, and I don't know the answer, do I? But what if it's negative? Don't I have to change the sign direction? I do, don't I? So if this, now this is if X is positive. If X is positive. So if X is a positive number, I get this answer, no problem. Okay, so X is less than 1/2. But what if X is negative? So what if this number is a negative number? Okay, so if X is negative, this here will be negative. So if X is negative and I multiply by that number, I have to change the sign, just like we learned with inequalities. So if X is negative, I would have to do changing the sign. So I'm going to get up with 1 is less than 2X. So I do the same procedure, but I have to change the sign. That's what I've done here. So I'm going to add 1 is less than 2X. 2X is greater than 1. X is greater than 1/2. Like that. So you end up with 2 parts to the solution. So by graphing, let's just double check that. Oops. So if we were doing this by, and I'm not sure about that solution. So 1 on X, I'll show you what the graph 1 on X looks like. It looks like this. And this is the point 1, 1. And then it will also be on this side. And this will be -1, -1. So this line here, what I've just drawn there is the graph 1 on X here. Now this is 2. So I'm going to draw the line y equals 2. So I think part of this solution is not correct. So the line y equals 2 would be about here. So what I want to know, this solution is not valid. This one doesn't work. So I'll show you why. Where is the graph, this graph greater than the value 2? That only occurs in here. You see that bit? So this is 1 on X. Where is 1 on X, the value more than 2? That is only here, where the graph is above the 2 value here. So our solution then is between 0, it's going to be like this. So 0, X, and I think it's going to be 1/2. So that's the actual answer. But I'm going to show you another way to do this. You see how confusing this is? And that's why I did it to confuse you, and I don't want you to do it this way. It can be graphed, but not by hand. It's too difficult to solve these. So let me show you how to do this and get that answer. There are a couple of ways, and I'll show you the main way that you should do this question. So if I'm going to ask you to solve 1 on x greater than 2, right, first step, and I'll follow this procedure here for this question as well. So what I do, I bring the 2 over. So I'm going to get 1 on x minus 2 greater than 0. So you can write this down if you want. So I try to make a fraction here. I'm trying to make a fraction here, okay? So I'm going to combine this as one fraction, right? The same way that I've done it here, like that there. So to make this a single fraction, we have an x here. So let's multiply x top and bottom like that. So you're going to get 1 minus 2x on x greater than 0. So this is the equation we're going to think about now. Now, next step. So don't follow that one. Let's do the easy one. So look at the top and bottom. So now I want what I call critical points. The same way that when we use critical point when we solve polynomial inequality. So we'll do it exactly the same method. So critical point from the numerator. So we have 1 minus 2x. We let that equal 0. So everyone we let equal 0. So 2x equals 1, x equals 1/2. So this is your first critical point here. So this is the value that makes the numerator 0. So this value makes the numerator equals 0. So what about the denominator? What value makes the denominator 0? It has to be 0, isn't it? So this critical point, that's your, let's call that numerator, and let's call this denominator like that. So here, x must be 0. Because if x is 0, the denominator will be 0. So we're interested in these critical points. This is where your answer changes at the critical point. So you can copy this down because this is how we do every question like this. There are other methods, but this is the method I recommend because it's the fastest method to solve. So now we make a number line like we did with polynomials. And we have a 0, 1, 2, 3, minus 1, minus 2, minus 3. Okay, so now we mark on the critical points, which are going to be 0. But notice we have there's no equal sign here. So that means we use an open circle for both of them critical points. Open circle. We can't equal 0. If we equal 0, it's not, we can't include 0 anyway, because 0 makes this denominator 0, and that's not allowed. So 0 cannot be part of your answer. Do you see that? Because if your denominator is 0, there would be no solution at that point because it's undefined at 0. Just like when we talked about functions, the same idea. So this is 1/2. So we go to 1/2, which is here. So we do another open circle. I should have made it bigger, shouldn't I? So this is 1/2. So they're very close together. So what I want to do now is choose numbers and see if it's true or false. So if you put -3 into your expression, we can actually put it into this original one too. So maybe put it in that one there. So 1 on -3 greater than 2. -1/3 greater than 2, false. And if you put it in this one, you'll get the same. I'm doing that one because it looks much easier, isn't it? So I substitute -3 into my original statement. You can do that one as well. and it's false. So let's try 3 up on this end. So 1 on 3 greater than 2, false again. So this is also false. So it looks like my answer is going to be in here. So we can't use 0 or a half. So let's try 1/3. What if x equals a third? We'll have 1 on a third, which is greater than 2, which is true because 1 on a third is 3. Just bring it up and flip it over. True. So that means our solution is actually here, as I showed you earlier, between 0 and a half. If you try any other number here, they are going to be false. So you only have to try once. So you've got to try everywhere around the critical points. So on the left, over this side, on the right, and also in between the critical point, which I did here. I put in 1/3 here. So that's your answer for that one. So 0 less than x less than a half. And we can also get that by graphing, but as I mentioned, we wouldn't bother to graph these because they are actually take too long. Okay, so let's go down. I won't explain that example because it's the same thing. Let's look at exercise here. Not that one. This one here. Come to here. Okay, so let's do this one. What's the time? Is our time run out? 10, 20, 11, 20, 11, 10. Our time's run out. So I'm going to do this on tomorrow. Okay, but if you want to try it yourself, let me show you real quick. The critical points would be 4. 4 minus 4 is 0. So you can write this down now. And the critical point here would be -2, because that would make the denominator 0 as well. So you got your critical points from the numerator, and this one is from the denominator. So you make a number line. We put 0, 1, 2, 3, 4, 5. 4 is here. 1, 2, 3, 4, -5 is here. Now notice we have an equal sign. So we're going to use that idea when we mark off these points. Now, -2 is still not allowed. You see, if x is -2, you'll get 0 denominator. And you can't have 0 denominators. So we can't have -2 as the part of the answer. So we do open circle for -2, not allowed. But 4 can be allowed because 4 minus 4 equals 0. And we have an equal sign here. So do you see that? If I put 4 in, this will still be true when x equals 4. So if you put 4 in, no problem. You're going to get 0 on the top, so you'll get equals 0. So that's no problem. So that would be 4. So I'll let you check the points to find a solution. So check x equals -5. True or false? Check 0. X equals 0. True or false? We want it to be true, remember. And check 5, another point. So we check 3 different locations, true or false. And if it's true, that's your answer. That's what give you the solution to the problem. Right, I'll stop now because we're over time, but we'll continue this tomorrow. Because this, I'm jumping to these kinds of questions because this is part of the curriculum. Okay, so it's something you do need to learn in grade 10. So even though I probably don't test you on it, we might review it in semester 2 anyway. All right, so I'll stop there. And then, because I spoke a lot already. So tomorrow, hopefully you'll pick it up and you'll be able to do some yourself tomorrow. Because they're done the same way as polynomial. This method is the same as polynomials. All right, I'll see you tomorrow then. All right, bye-bye. Have a good day.
Bye-bye, Doctor.
Bye, Doctor.
Bye bye.
All right, see ya.